Hi, in this video we are going to discuss normal distribution. We're going to start off from the very basics of normal distribution. So let's just get started. So a normal distribution is basically a continuous distribution. In our previous lectures we have discussed binomial distribution and discrete random variable. So I'll first discuss the difference between discrete distribution and a continuous distribution. So discrete is basically where you have a distinct separate values that are being taken, like 1 2 3, usually whole numbers like 1 2 3 with any value in between cannot come in. For example, number of students in a class, that's a discrete distribution. When I talk about the continuous distribution, that is where you can have a range of values, for instance heights of students in a class, and that could range from, let's say, 130 centimeters to 190 centimeters, with a value being 150.75 even coming in. So you can have a range of values in a continuous distribution. Now a normal distribution, and in our when we did box and whisker plots, we discussed different distributions, which was positively skewed distribution, negatively skewed distribution, and normal distribution, which was symmetric around the mean. A symmetric distribution is basically where the data is evenly spread out. So if you see in here, the data is evenly spread out. It's right in the middle, the mean, median, and the mode, and the data is evenly spread out. When I say evenly spread out, that's similar to having numbers like, let's say, 1 till 100, 1 2 3 4. They're evenly spread out. So the data is evenly spread out, the data is huge, and it's normally distributed. So it's a symmetric distribution and it's a continuous distribution. Now, how did we define a binomial distribution? We defined a binomial distribution with n and a p only, which was the number of trials, and p being the probability of your success. That was how you defined normal distribution, and that was a discrete distribution, distinct values. Here you have a range of values, and when I've plot this curve, and later on we're going to discuss probability density functions later on in the course in our S2 syllabus, and this is basically a probability density function. Basically you're plotting probability densities along with the continuous variable that you're taking. So we don't need to get into that much detail of how do you calculate that, but it's basically plotting all of the probabilities along with the continuous variable that you are taking. So you will notice that it's evenly spread out throughout the distribution. Now how do you define all of this normal distribution? You define it with the mean, which is mu, and the variance, which is also known as the standard deviation squared. So mean and the variance is what defines a normal distribution. We'll look into the numbers and all. So right now we need to know a normal distribution is a symmetric distribution, evenly spread out. It's for a continuous random variable, and it's defined with mean and the variance. That is how it is normally recorded, mean and the variance. And we need to know that because it's evenly distributed, the mean, median, and the mode, they're all equal in this case. The mean, median, and the mode, they're all equal. Now moving on, we need to have those values that you plot. There's a standardized normal distribution table. You might have seen this in your books as well. There's this table that is given, and there's z written in there. That is basically a standardized normal distribution table given to you. That basically has those values for probabilities plotted on the graph, written down as values. The table records the values for z along with their probabilities. So it's basically reading off the graph only, but that has been done for you on the table only. So this standardized normal distribution table is only valid for the mean of 0 and for a variance of 1. For a mean of 0 and a variance of 1. This is a standardized normal distribution table. Later on we're going to see how to cater to different distributions, but right now we need to know what exactly is a normal distribution, standardized normal distribution, which we'll also call it as a z table, as a normal distribution table. So it is only for mean of 0 and variance of 1. That table that you see, I'll now discuss the table, that has the z values along with the probabilities. And one thing that we need to know is that in that table, or in that probability density function, the curve that you make, the area under the curve will give you the probability. I'll give you another example. You have done histograms, and you know that the area under the bar in that case gives you the frequencies. In a frequency distribution graph, in a histogram, the area under the bar gives you the frequencies. Here the area under the curve gives you the probabilities, because it's a probability density function. So that area gives you the probability. This z table also gives you the probability. So basically it has found out the area under the graph for different values of z. So for instance, if you have a number, let's say probability of z less than 1.5, keep one more thing in mind, that these z values, the area that has been defined, are all for z values lesser than a certain number. The area that is defined is for z less than a certain number. So for instance, when you have probability of z less than 1.5, if you go on to that table and if you see the table, that table has been made in this way. I'm just making an extract out of it. So if you see the 1.5, 0 with it, this number here basically represents the probability that corresponds to less than 1.50. Z less than 1.50 has an area, has a probability of 0.9332. So 1.5, anything below that is a 0.9332. This area is all 0.9332. This is such that the mean is 0. So 1.5 is in here. Less than 1.5 is all of this area. So probability is the area under the graph. So less than 1.53 has, less than 1.5 has an area of 0.9332, which is the probability. Let me give you a few more examples. So let's say if you have so this is 0.9332. Let's say when you have 1.53, now when you have less than 1.53, so you will go on to 1.5 and the second decimal is denoted by this. So the number in here will give you the probability of z being less than 1.53, which will come out to be now 0.9370. So 0.9370 in here is the probability of z being less than 1.53, or the area under this graph being 0.9370. Right? Let me give you one more example. Increase the decimal one more. So if it is 1.534, now in that case, if you notice one thing in your z table, there is this add and then there's a 4 written. So 1.534 basically means 1.53 in here. This 4 in here add basically has to be added to the last digit. When I say last digit, in that you would see a 5 in here. This 5 needs to be added to this last digit. So in this case, it will be 0.9375. 9370, add 5 to the last digit, and that will give you a 9375. A 9375. That's the probability of z less than 1.534. Right? So you need to keep in mind that this is for values of z less than a certain number. So what if it is greater than a certain number? Let's say a greater than 1.5 only. Now one thing that I need to know is that the entire area, the total area is equivalent to 1. Why? Because the total probability, the sum of all the probabilities is equal to 1. So if I know the value, the probability for less than a certain number, how do I get the value for the greater than? I can do a 1 minus the less than value. So if it is greater than 1.5, less than 1.5 is 0.9332. So greater than would be 1 minus 0.9332. I hope you're all okay with the greater than sign, which is 1 minus this number only, because the total probability is 1. This less than part is 9332. So the greater than part will be 1 minus 0.9332. Right? Now let's do a few more examples. For instance, if you have probability of z less than minus 1.5, let me first draw the graph. Less than minus 1.5 basically represents this area. Now in your table you don't have values that are negative for z. So what do you do in that case? Now because the data is symmetric, it's a normal distribution. Isn't this area similar to, or exactly rather equal to, greater than 1.5? Isn't this area and that area the same? And this is something that we just did. Greater than 1.5 was found out as 1 minus z less than 1.5. So this was done with 1 minus 0.9332. So you could say that if it is z greater than 1.5, it was 1 minus z less than 1.5. If it is z less than minus 1.5, it's the same thing as 1 minus z less than 5. And later on we're going to see that we can generalize all these things. Right now we need to understand all of these. It's very important to get the hang of it. So z greater than 1.5, the same thing as z less than minus 1.5, which was 1 minus z less than 1.5. So directly you can write that as well. So the areas are the same. If you get the hang of the areas, it's pretty easy and straightforward. The next example is the probability of z greater than minus 1.5. Let's see what that area is. So minus 1.5, greater than that will be all of this area. Because again the data is symmetric, can I even say that this area is equivalent to the probability of z being less than 1.5. This area and this area, they're both the same. Why? Because it's a normal distribution, it's a symmetric distribution. All of this area is the same as all of this area. So if it is z greater than minus 1.5, I can first say that it's the same thing as z being less than 1.5, and which was 0.9332. Now moving on, if you have probability of z between 1.1 and 1.5. Now this is very important. A lot of the students don't really appreciate and understand this. So when it says the probability of z being between 1.1 and 1.5, they're basically asking for the area between 1.1 and 1.5. For the area between 1.1 and 1.5. So if I were to make a graph, again it will be between 1.1 and 1.5 is this area. Now in my z table, when I find out 1.5, that will give me all of this area. Then when I read off 1.1, that will give me all of this area. So I basically need to subtract these two. Let me first write it down. The probability of z being less than 1.5 will give you all of this. Subtract the probability of z less than 1.1. Now a lot of students get confused with this. They when you literally see this, z is greater than 1.5 and z is less than 1.1, greater than 1.1 and less than 1.5. But the probability basically means that it's the area between these two. So when you read off 1.5, it gives you all of this. And when you read off 1.1, that gives you all of this. When you subtract these two, that will be the answer then. So it's less than 1.5 minus less than 1.1, not greater than, not greater than. It's less than 1.1 because it's the areas that you are taking into account. So the areas need to be subtracted. All of 1.5 minus all of 1.1 will give you the area between 1.1 and 1.5. So to take that into account, and that will give you 9332 and 8643, right? Now let me generalize all of the things that we've done. So when you have probability of z less than a, that is the normal one that you would read. So if you get z greater than a, it's equivalent to 1 minus z less than a. Just keep in mind that the normal distribution table will give you values that are less than z values, less than a certain number. And that is why I'm writing it all in those numbers. So if it is z less than minus a, the second example that we took, it will be 1 minus z less than a. It is equivalent to z greater than a. Greater than a and less than minus a is the same thing, so both are the same. Greater than minus a is equivalent to z less than a, which was the third example that we took. And then between a and b is simply equivalent to probability of z less than b minus the probability of z less than a. This is what we need to keep in mind. These are all the rules there. You can extract more rules out of it, and later on when we will be doing the questions and practicing questions, we'll see how to really use them, and then the concepts that will take you further in normal distribution. These are the basics that we have just discussed. We will build upon this by doing more questions from the book and from the past papers then. So in the next video, we will be doing some simple questions first, and then we'll be taking it forward. Thank you very much for this video.